Example 4 will require integrating by part twice, but the result will lead you to another variation of this technique. In this example, we need to evaluate a product that has a trig function in it. It will be e to the x sine x dx, like so. Choices. This time, I'll choose u to be e to the x, and therefore dv will be sine x dx. And I'll tell you, after the exercise, I'll tell you why I chose like that. Therefore, du will be e to the x dx, and v is negative cosine x. Again, we ignore the c, we'll add those at the end. So, the integral of u dv, the integral of e to the x sine x dx, equals u times v. Well, u times v is e to the x times negative cosine x minus the integral of v du, the integral of negative cosine x, and du is e to the x dx. So let's see what is the result. We end up having negative e to the x cosine x, and double negative make it positive, the integral of e to the x cosine x dx. So we have this integral that we need to evaluate, and I'll mark this as before as equation star. So so we need to evaluate the integral of e to the x cosine x dx. Okay, I'll choose, again, I'll let u as before, e to the x, and dv will be cosine x dx, and du e to the x dx, and v will be now the antiderivative of cosine x is the sine x. All right, so apply the integration by part rule one more time, and the integral of e to the x cosine x dx. So this is u dv, the integral of u dv, equals u times v, in this case e to the x sine x, minus the integral of v du, minus the integral of sine x times e to the x dx. Isn't it what we started with? If I write it as e to the x sine x minus the integral of e to the x sine x dx, then, and now plug the result in equation star, notice that this is what we started with, except it's negative on this side. So let's plug it back in the equation star. Okay, so here's the equation, the star equation, e to the x sine x dx equal, we have negative e to the x cosine x, and then plus this result, right? And e to the x sine x minus the integral e to the x sine x dx. Once again, we have this and this on either side of the equation, and one has a negative up front. So what happened is we add this integral to both sides. Okay, so add the integral of e to the x sine x dx to both sides and get 2 times the integral of e to the x sine x dx equals negative e to the x cosine x plus e to the x sine x. Plus, now I can put the c here, okay, except I'll call it c1. And finally, we get the result. The integral of e to the x sine x dx will be, I'm going to factor out e to the x, and I have sine a, first of all, I have 1/2 in front, so let me make sure to write it, because I'm dividing everything by 2. So I have 1/2, and the common factor is e to the x, so I have 1/2 e to the x, and I have sine x minus cosine x plus c, and this is the answer where c is half of c1. That's why we really don't worry about intermittent value of c, because we can always adjust the constant. So where c equals c1 divided by 2. Again, we can check it. I'll let you check it at home.